Hello friends, welcome back. In today's lecture, I am Dr. Milind Meshram, working as an assistant professor in the Department of Chemistry, Chem College, Nashik. In the previous lecture, we have seen 1,1 carbon-carbon disconnections. Alright, so 1,1 carbon-carbon disconnection is basically the disconnection which is relied on the reactions of carbon electrophile with carbon nucleophilic functional group. Okay, alternatively the reactions of carbon nucleophilic functional group such as Grignard reagent, the reaction of Grignard reagent with electrophilic functional group allows us to do carbon-carbon disconnections on alcohol. Alright, so we have seen this 1,1 carbon-carbon disconnection in the previous lecture. So today we will discuss the other example which is also involves the 1,1 carbon-carbon disconnections. So 1,1 carbon-carbon disconnection can be seen in the tertiary alcohol. Okay, suppose we have the target molecule that for example tertiary alcohol, and the tertiary alcohol is having two similar substituents. Okay, so in this in such kind of target molecule we can do double disconnection. Okay, double disconnection can be a shortcut. Okay, for example, so for example this tertiary alcohol, so we have these two groups, means similar two groups, so we can disconnect at the same time like this. So we would get this ester functionality and this Grignard reagent. Alright, 2 moles. So in this case we can see the double disconnections. Okay, so let us have the example which involves double disconnection, 1,1 carbon-carbon disconnection which involves double disconnection which can be a shortcut. So let us see the retrocentric analysis. Okay, this is the 10 precursor. Alright, so retrosynthetic analysis for this 10 precursor. So this is our target molecule. So in this tertiary alcohol we have these two similar functional group. Okay, phenyl functional group. So this tertiary alcohol can be obtained from ester and 2 moles of Grignard reagent. Okay, so this tertiary alcohol can be obtained by using Grignard reagent and ester. So let us put this retrosynthetic arrow. So we have 2,1,1 carbon-carbon disconnection. Alright. So we would get this ester plus 2 phenyl magnesium bromide Grignard reagent. Alright. So when you disconnect this, when you apply this 1,1 carbon-carbon disconnection, so we could get this ester and this Grignard reagent. In this, basically this tertiary alcohol, when that tertiary alcohol is having two similar groups, so it's obvious to have the starting precursor like ester and 2 mole of Grignard reagent. And when you disconnect it further, so we have here 1, 2, 3. Okay, this Cn disconnection, Cn amine bond 1, 2, 3, 1, 3 disconnection. So we could get this alpha beta unsaturated compound. So I am not writing synthons, and here is secondary amine. Okay. In this way, we can disconnect this bond. So this, suppose if you consider this as a target molecule, you would think about this 1,3 disconnections. Okay. After disconnecting this bond, we could get this alpha beta unsaturated carbonyl compound, that is ester, and this secondary amine. So this is the Michael acceptor. Alright. So in this way we can do the retrosynthetic analysis for this pyrene precursor. When you look at this molecule, you will observe the presence of tertiary alcohol and having two similar groups. So it's obvious we have the disconnections of 1,1 carbon-carbon disconnection to get this ester and 2 mole of Grignard reagent. And further, this molecule is having 1,3 disconnection. So we can disconnect this Cn amine bond to get this alpha beta unsaturated carbonyl compound and this secondary amine. So let us have its forward synthesis. When you treat this it gives rise to, when you react the secondary amine, it will attack at alpha beta unsaturated carbonyl compound. It gives this intermediate, and finally we would get is compound. Alright. Then the treatment of 2 mole of phenyl magnesium bromide, okay, followed by acid 1 cup, you will get our target molecule. When the treatment of this secondary amine with alpha beta unsaturated compound, it gives this intermediate, then finally it leads to the formation of this compound, and then finally the treatment of this ester with 2 mole of Grignard reagent, phenyl magnesium bromide, after acid hydrolysis gave this tertiary alcohol. Okay, this is our target molecules. So in this way we can achieve the synthesis of tertiary alcohol, which involve the reaction of ester with 2 mole of Grignard reagent. Alright, so let us have another example. So in this case, in the synthesis of this tertiary alcohol, which involves the ester, 2 mole of Grignard reagent is added to ester. So in this ester case, with 2 mole of Grignard reagent. Okay, so it gives tertiary alcohol. Okay, so this is the fact. So when ester reacts with 2 moles of Grignard reagent, it gives the tertiary alcohol. But when you do the retrosynthetic analysis for this particular ketone like this, okay, so this will not be a reliable reaction. Okay, this is not a reliable. So in ester case, first molecule will react, first molecule of Grignard reagent will react to give ketone. Again, second molecule will react with ketone to give the tertiary alcohol. But when you consider ketone and want to do retrosynthetic analysis, if you do this retrosynthetic analysis, so this is not a reliable disconnection. Alright, so let's have another example. So chlorphendiol. So let us have its retrosynthetic analysis. So this is our target molecule. This is our target molecule, chlorphendienol. So when you look at this molecule, you will observe there is a presence of keto group. Okay. So here, so you will not find the reliable reactions to get this ketone. Okay. So what is the solution? We can apply. So as per our guideline 5, convert the oxygen-based functional group to facilitate the carbon-carbon disconnections. Okay. So if you convert this functional group oxygen, this carbonyl group to alcohol, so there would be a possible disconnection, isn't it? So let's have this functional group interconversion. Let's put this retrosynthetic analysis, functional group interconversion. Alright. So this ketone can be transformed to alcohol. Okay. So this alcohol can be oxidized. Okay. This is the oxidation. So here we have done DHA. This carbonyl functionality transformed into alcohol. Now you can think about this carbon-carbon disconnection. Okay. So let us break this bond. So we have one carbon-carbon disconnection. We could get this to fragment when we will have this positive charge and other would have this negative charge. As I have mentioned it before, this carbon nucleophile corresponds to the Grignard reagent, for example. Okay. So let us translate these synthons. So this would be the benzaldehyde and this would be the Grignard reagent. Okay. This is our Grignard reagent. So what we have done, in our target molecule there is a presence of keto group. So this functional group is not suitable for this disconnection here at this stage. So we have converted this keto group into alcohol. Okay. When you have this alcohol functionality in our substrate, so we could think about this 1,1 carbon-carbon disconnections. So after having this 1,1 carbon-carbon disconnections, so we could get these two fragments, and these two fragments can be transformed into their respective chemical reagents. Okay. One is benzaldehyde and other phenyl Grignard reagent. Okay. Phenyl magnesium bromide. So let us have its forward synthesis. Synthesis. Grignard reagent is prepared from this dichlorobenzene treated with magnesium turning in the presence of diethyl ether. Okay, this is dichlorobenzene. in the presence of diethyl ether, it gives this Grignard reagent. Okay. So when you treat this dichlorobenzene with magnesium turning in the presence of diethyl ether, it gives the vinyl magnesium chloride. And next, when you treat this with this dichlorobenzene reacts with magnesium turning in the presence of diethyl ether, it gives the phenyl magnesium chloride. This is the Grignard reagent, which on treatment with benzaldehyde. This is benzaldehyde. It gives this salt. Finally, the treatment of this acid hydrolysis, it generates this secondary alcohol. Alright, and finally, the oxidation of this secondary alcohol, we could generate our desired target molecule. So this is our target molecule. So synthesis is very simple. So we have this dichlorobenzene. It reacts with magnesium turning in the presence of diethyl ether. It gives the magnesium, phenyl magnesium chloride, Grignard reagent, which on treatment with benzaldehyde, okay, it gives this salt. Finally, the treatment of this acid, it gives the secondary alcohol. And in the end, when you treat this secondary alcohol with oxidizing agent, okay, so it oxidizes this alcohol to give this ketone. Okay, so in this way we can achieve the synthesis of secondary, achieve the synthesis of this ketone. All right. So these 1,1 carbon-carbon disconnections we have seen in ester secondary alcohol. Okay, we are this 1,1 carbon-carbon disconnections which involves in tertiary alcohol, secondary alcohol, and this ketone. Ketone means after functional group interconversion we could get secondary alcohol. So we will see this 1,1 disconnection. Suppose we have this secondary alcohol when you have 1,1 carbon-carbon disconnection, okay, so we could get this aldehyde plus R magnesium halide, Grignard reagent. have this ketone, so in first step we need to convert this ketone into alcohol, HCl. Then 1 carbon disconnection. So again we can get this aldehyde plus this lignite reagent. We consider tertiary alcohol R1 and R dash and R double dash. So it is having 1 disconnection. Okay, let's say this one. So we would get this ketone plus this RMgX. This is tertiary alcohol. Suppose another tertiary alcohol we have, which is having this 2 R group similar. So in this case we can do double 1 carbon disconnection. Okay, like this. So we would generate this ester plus is both the R groups are similar, so we can generate ester plus this R1 R dash NGX. Okay, so this is for tertiary alcohol, and this is for secondary alcohol. Alright. So when you have the secondary alcohol, for example this one, so you can have 1 carbon disconnection, which disconnect. Okay, here 1 disconnection can be done to give these 2 chemical equivalents. Okay, aldehyde plus lignite reagent. Alright. So when you have this ketone, so this ketone can be converted into alcohol, the secondary alcohol. Again the similar fashion we can do the 1 disconnection to get this aldehyde and lignite reagent. But when you have the tertiary alcohol, so in first case these 2 R groups are different. Okay, 2 R groups are different. So in this case we have the 1 carbon disconnection to get this ketone plus lignite reagent. On the other hand, if your tertiary alcohol is having 2 similar groups, okay, alkyl or aryl groups, similar group, so in such kind of disconnection, okay, in such kind of substrate, we can have 1 carbon disconnection to get ester and 2 mole of lignite reagent. So this is how we can summarize this 1 carbon disconnections. So this is all about the today's topic. I hope you enjoyed this and understood as well. In the next lecture we will see 2 group disconnections, where we will see 1,3 difunctional group disconnections. Alright, thank you.